I'm Balaji, and welcome to another professional prep video. In today's professional prep video, we will be talking about the fundamental theorem of calculus, part 2. So, there are two parts to the fundamental theorem of calculus, and one of them you've seen in the last video, which was basically where you plug in the upper bound into the function, and now this is part 2. So, now let me explain part 2 by giving like a quote-unquote formula, then we'll do one problem so you guys can understand it, alright? So this is like the formula. So say if we had an integral, right? And the lower bound was a and the upper bound was b, right? What we do is we'll obviously have like an f of x dx here, right? So say if we had some sort of function and there's an integral on it from a to b of f of x dx, then what you do is you take the antiderivative of the upper bound, so f of b, then subtract that from f of a. So this is the antiderivative of the upper bound. This is the antiderivative of the, no, this is the upper bound, antiderivative of the upper bound, and this is the antiderivative of the lower bound. Because see, A is the lower bound, B is the upper bound. So hopefully that made sense. Now let's go into a quick problem so that you can understand how the fundamental theorem of calculus part 2 works. So say if you had an integral going from 0 to 4 of x squared plus x over the square root of x dx. Alright, now the next step we would want to do in this problem is separate out the x squared and root x, and then the x and root x. This is because then we could probably even use the power rule, take the antiderivative, and then we can plug in our bounds as said in the formula. Alright, so next step it would be same thing for 0, and it'd be x squared over root x plus x over root x. Alright, now that would then be equal to, like, using, like, just putting this into a x to an exponent, it would then be integral of 4 to 0 of x to 3 halves plus x to the 1 half dx. Alright, and essentially this is what you have to do. This is the big step right here. Turning this fraction into an exponent. Essentially, you'll just multiply by the denominator and you should get x to the 3 halves and then plus x to the 1 half. Alright, so the next step after you do this is, let's just do the power rule. So then it'd become 2/3 x to the 5 halves and then you add 2/3 x to the 3 halves, and this will all be from 0 to 4. Now, what do you think we would do after this? So now we sort of got like our general antiderivative of our original function, right? So this is the antiderivative. And now this is where the FTC part 2 kicks in, the fundamental theorem of calculus part 2. Essentially what you do is you plug in 4 into all these x values and then 0 into these x values and you subtract them from each other. So it'll look like this. 2/3 4 to the 5 halves plus 2/3 4 to the 3 halves minus, now this is the lower bound, 2/3 0 to the 5/2 plus 2/3 0, sorry for messy handwriting, to the 3/2, yeah. This is a 3, by the way. Yep. So this is what it would look like. And obviously, since these are gonna be 0, this would cross out. And now we just evaluate this. And when I put it into my calculator, I get 64/5 plus 16/3. And you can leave it like this, like you don't really have to simplify. If you do, I'm pretty sure you guys will know how to simplify this. But this is the general idea of how to solve problems using the fundamental theorem of calculus part 2. Just put it right here. Alright, cool. So yeah, what happened? Alright, there we go. So that is the fundamental theorem of calculus part 2. If you have any questions, please put them in the comments below and we will be answering any of your questions. Also, check out our newly created Instagram profile. It has a lot of pictures and graphics of current Java concepts, and we really hope that it can bolster new ideas to you guys and just a review of the content that we've been producing. So please drop a follow on Instagram and also the rest of our social media. Other than that, thank you so much and have a good day.